All right, so now let's chat about the second type of identities. They're called co-function identities. Okay, so you may have already noticed this relationship when we were chatting about the unit circles and dealing with the quizzes that we did. Okay, I'm intentionally covering this up. Okay, so I want you to think about this. If you remember back to the unit circle, gosh, I forgot how good I am at drawing circles. Okay, if you remember at 30 degrees, I want you to pause and think about this. Don't just listen. I want you to try to remember what was the sine of 30 at this given point, okay? So pause and think about. So sine of 30, if you remember, comes from that 30-degree triangle. So this is square root 3 over 2. This is 1/2, which means my x-coordinate, square root 3 over 2, my y-coordinate is 1/2. So sine of 30 degrees is this y-coordinate, so it's 1/2, right? 1/2. And if you jump up to this 60-degree triangle, right? What happened to these two coordinates? Well, if you remember, they flip-flopped, so it was 1/2 square root 3 over 2. And then this one in between, since we're filling this out, I'm just gonna go ahead and finish, is just square root 2 over 2. Okay, so one thing that you may or may not have already realized is in this switching, what is the relationship between sine of 30 and cosine of 60? What type of angles are those to one another? Hope you're not cheating and looking ahead on your paper, because it talks about it on here, but the sine and cosine have the same angle same value, when their angles are complementary. So notice sine of 30, cosine of 60. 30 plus 60 is 90. That makes those two angles complementary. Sine and cosine of 45 degrees, that's that exact same value. That's that square root 2 over 2. And then same is true, sine 60 is the same as cosine of 30. So sine 60 is that square root 3 over 2. Cosine 30 is also square root 3 over 2. Those two are the same. So this leads us to the principle that says the sine of theta is equal to the cosine of 90 degrees minus theta. And remember, this is what makes those two complementary, that 90 minus theta. Okay? Same is true for secant and cosecant, and for tangent and cotangent. These are what are called co-functions. Okay? So we kind of talked about these in different terms, but these are what are called co-functions. And that's how they operate. They follow those similar patterns. So you can build all of these identities out of this principle. So we have the sine of theta is equal to cosine of 90 minus theta. Tangent is equal to cotangent, 90 minus theta. Cosecant to secant, 90 minus theta. And then you see from here, cosine, cotangent, secant, and cosecant. Okay, so if you're dealing with radians, you can also replace that 90 degrees with pi over 2. Remember on the unit circle, this is 90 degrees or pi over 2. So you can replace those two synonymously depending on if you're in degrees or radians. Okay, so you can remember sine and cosine are co-functions, secant and cosecant are co-functions, tangent and cotangent are co-functions. So if you are looking at the mnemonic here, the underlined part is the co. So each one of them has a co. Sine and cosine, tangent and cotangent, secant and cosecant. Those are co-functions. Okay, and then at the bottom you'll note that these things are true, these principles are true, same way with any power. So if this is true, sine of theta equals cosine of 90 minus theta, everything in between also works. And the reason you see these things worked out, this is just another way to write sine squared of theta, but this is a type of function, whereas this is saying it's sine of theta squared. So it looks different, it means slightly different things. When it's written like that, you can't just go ahead and replace it. When it's written like this, you know sine of theta equals cosine 90 minus theta. So anywhere you see sine of theta here, you can replace it with this piece here to lead to this. So I want you to note the difference in this little squared here and the squared on the outside. Those are two different things, okay? So I don't want to say it's the same as when you're dealing with power functions. If it's like x minus 3 squared, you have to like actually do x minus 3 times x minus 3. But it's a similar principle to that. So just be careful in your work that you do denote that these are different kinds of things.